Alright, in this problem we want to solve for the variable p. Now, if you look here, we have p's on both top and bottom of this fraction to the right. So we need to do some finagling in order to get all of our p's all on top and on the same side of the equation. So one thing I like to do whenever I see an equation with fractions is to get rid of the fractions by multiplying both sides by the least common denominator. And since I only have one denominator, which is p minus f, I'm going to multiply both sides by p minus f. Alright, so then I'm going to distribute it to each term, and I get p minus f times q equals p minus f times pf all over p minus f. Alright, so I've just distributed this whole expression, p minus f. Alright, so now it cancels on the right, and I've succeeded in getting all the p's onto the top. But what I don't have now is all the p's on one side. So I'm going to move, well, first thing I'm going to do is distribute this q, and I get pq minus fq equals p times f. Alright, so I'm getting closer. I'm going to move this p, well actually this term pf, over here, and then fq over here. So I have p times q minus p times f equals, and if I move the minus fq over here, it's a positive fq on the right. So close! Alright, I want to get p by itself, but it's part of two terms here, so I'm going to factor it out. I factor it out, and I'm left behind a q minus f equals fq. Last step, I'm going to divide both sides by q minus f. Now, p sits alone on the right, and this is my expression. So if I were to rewrite this, p equals f times q all over q minus f. Now this is true provided that q does not equal f.